Sorry. In regards to multics, what is this ring 0 program? Where did that come from?
Alright. Multics memory system gets... So, I'm just going to read off the whole thing that multics does when it tries to create a memory reference. So segment number is used to find the segment directory. Keep in mind that first it has the segments of all the memory, and each segment leads to a page, or has a page in it that then goes somewhere else. It's a way to basically make, because pages are constant size, it's a way to make variable size pages.
Gotcha.
So segment number is used to find the segment descriptor. Then you have to check a check was made to see if the segment's page table was in memory. If it was located. If it was not, a segment fault occurs. If there was a protection violation, a fault trap occurs, which was basically a form of error handling. That was step 2. I should be saying this aloud. Step 3, a page table entry for the requested virtual page was examined. If the page itself was not in memory, a page fault was triggered, and if it was in memory, the main memory address of the start page was extracted. No, sorry. Say your question again. You said the 0 ring?
Yeah, just what is that? I don't really know. Where'd that come from? It's kind of out of nowhere.
This was from the video, right?
Yeah, I thought it was relevant.
The 0 ring is effectively operating system, or just kind of segments areas were numbered. It's 0. I mean, it's a much longer answer and a lamer. Sorry, but mine's much shorter. It's not. I know it's not the correct answer, but that's the best one I can give without going into like 3 hours. Here's multics.
Gotcha.
So does it have to do with like kernel and user mode versus? I thought level 0 was like referring to programs that run like from the kernel or something, and anything above that.
No, because you don't, like, you run operating system in the kernel, right? So unless you're going to modify the operating system or long-term memory storage, why would you go in the kernel?
I don't know. That's what I thought it meant by when you said like level 0.
Level 0 memory sounds right if you're going to say you're going to mess with the kernel, but yeah, pass them. But typically, if you're going to store things in memory, and we're talking about storing things in memory, you don't just, oh, I'm going to shove it straight in the kernel.
Just go around and give the candy to everybody.
Yeah.
Everybody right now, or should I do this?
Yeah.
I think in terms of video games, I'm sorry, it's not really an answer to you.
No, it's fine.
You are group 2, right?
Yes, group 2.
Thank you. Okay.
Thank you for aiding my brain. That was the question. Anyone else?
Go ahead.
That was group 2. What's bigger, pages or segments?
Neither. Sorry. Segmentation. So pages is essentially chopping up the program you're using. So if you want to run Borderlands, as an example, you're going to get to the first level. We're only going to load that level because we don't need level 2. We just don't need it right now. That's, you're basically chopping your program up into pages to make it easier for memory to use, your computer to run the whole thing. While segments is, this program only takes up so many kilobytes, megabytes, gigabytes, so we're just going to place it in this chunk of our RAM or memory, and it's just going to spin up using that process.
Which group is that? Yeah, and the sizes of these are variable. They can be chosen. The size of the page can be chosen, and the size of the segment can be chosen by the designer.
Segments are typically variable, but pages based on the operating system have fixed sizes.
Right, but the designers of the system can choose the size of the page.
So segmentation isn't splitting up the program, but it's set finding a slot not big enough for it?
Yes, when using only segmentation, you are still running the entire program.
Okay, but what exactly is that?
Which group were you?
Segment is a way to organize things logically. So you could have, like, an example of the book is that you can have a graphic library in its own segment, so that other segments with their own programs could reference that segment to get to the graphic library.
Yeah.
Okay, so just basically organizes full programs in memory. And make sure that eventually like these segments the memory so that everything has its space at the top. Okay. I mean,
Well,
I
top is irrelevant when you're talking about a computer. It doesn't know what top.
Well,
left,
yeah,
right,
I know. I just mean, like, they make sure that there's enough room for programs to run. Okay. So it's like a system that, it's like a defragmentation system, and that's basically its job.
No. Segmentation. So it's more of a conversation. Most operating systems end up running paging and segmentation by default. It's just you chop up the program into pieces, and then you fit each of the small pieces into what's using memory.
Okay.
So like all those wedges that came with the empty space, if we needed to, we would collapse them down to make a much larger space because, hey, one of them or the processor takes up more than the rest. But defragmentation is really a whole different. It's a similar but different.
Oh, no, I was just comparing it because it seems
Thank you for the question.
What's like the general advantage though if like you can't just page and just fit everything in? What's the advantage of just pre-assigning this space for this program? Why would you not just have an algorithm that just like randomly puts places and like fits it in somewhere, like even having things like interweave ridiculously?
I mean, okay, so you're asking me why you would set up an algorithm to do something when you could basically just have all your programs randomly jumbled in memory?
No, other way. Like, why would you? Yeah, why is it bad to have it randomly jumbled if it's still like findable and retrievable?
Not findable at all. It's randomly jumbled.
Well, I'm not. Well, I don't
It's
mean
almost
randomly jumbled.
guaranteed to get a page fault error.
The whole point of segmentation is so that it's modular and you can define each segment the way you want it to. So you can load your OS into a certain segment and make that segment protected. Whereas paging is just chopping it up to fit it.
Like, well, like you can definitely like there's risk of having unused space here, and you could fit more if you just use paging, right? Well, in some cases.
Yeah, that's why a lot of OSs will use both.
But even with both, if you would pre-assign a amount of memory that's like potentially used for a program, and then like, I guess it always doesn't always just fill it all the way up. It always will use all that entire space. So it's not a big deal, but there is a chance that it doesn't use all that space, and then you have wasted. Is that a possibility? I'm just asking.
I mean, technically speaking, the space is there. You can fill it all the way up. If you wanted to run 1 million programs and slow your computer down, I'll say it right now, your program's not going to run. Nothing is going to run if you max out memory capacity. But well,
So it's unrealistic to ever max out memory capacity anyway.
well, it's just why would you bother?
Yeah, a lot of the implementations of segmentation, like x86 and Multics, both have a table of like, most often used processes and segments and datas.
So how much of memory is usually used at a time? Then if it's not, didn't we say we need all the memory is being utilized a lot in modern operating systems?
Well, memory is at 4.1. Isn't maybe a percentage?
So it's 10%.
60%. It's different per computer because most computers only have a certain amount of memory or RAM access they can use. So ultimately what ends up happening, if you max out your memory, your computer's going to run really slow, obviously, because you're just using a lot of processing time. And two,
Going into virtual memory where it's going to start putting your stuff on the hard drive instead of into the RAM, and then it's going to go even slower.
technically it's already in virtual memory. It's using it right now.
Yeah, but once it fills up the random access memory, it starts putting it onto the hard drive.
Yeah.
So it's impractical to ever like make something that's designed to be running at max capacity because you never try to do that. Is what you're saying?
Well, maximum capacity is a variable term. You can always overclock your crap and have it run twice as fast and shorten its lifespan, right?
Okay, what's overclock?
Well, it's overclock.
That's not a processor speed.
It is processor speed, but so it's like maxing out memory, right? So why would you constantly push the limits of what your computer can do, as opposed to just letting it do what it does?
Yeah, I was just wondering about like the practicality of like why segmentation is useful. Because if you wanted to absolutely use everything, there seems to be wasted. There would be wasted RAM, like potentially.
Well, okay. So segmentation is a way for space allocation in the memory, while as paging turns what would be. Sorry, I had this all prepared, but I never got to use it. So let's say I want to just eat this candy bar. simple, stupid little thing, right? Well, I can't shove the whole thing in my mouth right now.
You could.
I could. But let's be honest, I might choke. It's a whole thing.
Not really, just chocolate.
Well,
I would just chew it up.
So I turn it into two smaller chocolate bars,
There you go.
right? So I use paging and it becomes two smaller chocolate bars. So now, yeah, you know, these are itty bitty ones that you can't see at all, which is why I didn't want to use this during the presentation. So this big one becomes two smaller ones. So now I just all at once. Oh, now I'm done eating that
And
one.
segmentation would say all crunch bars go over here, but what's the advantage of saying all crunch bars go over here, as opposed to just?
You want to use both because they don't. Do
Well,
the
yeah,
same
obviously,
thing.
no, obviously you do both, but I'm saying, I'm trying to figure out what's the main advantage of pre-assigning like some space to be used for crunch bar, or whatever the program is.
Like you could just have paging where like you just have your entire memory page.
Yeah.
But the problem is it's just unwieldy. Like you have memory address like thousands and thousands of. I think he has something to
I have a
say.
metaphor.
Yeah.
So paging is like splitting your giant chocolate bar into smaller chocolate bars. But segmentation is like sorting all your Milky Ways to one side and all your whatever's to the
So,
other side.
another
So
way
that
is
it's
like-
easier to eat them. You don't have to like decide where is the Milky Way and like sort through like a
Yeah,
cloud.
but what does that matter if it's like a
How about this? It's like pages of just like information in a book. So like you can just have all your pages laid out. But with segmentation is saying, all right, we're gonna put all these pages into this book. We're gonna put all these pages into this book, and then like as you get to architecture, like even the books are arranged in the library into this bookshelf.
You're not in the same group.
And that's what segmentation is.
So why does that matter if it's like?
Okay, which group are you?
Just like looking at a
Sorry.
table and finding it somewhere, like this is something taking it in.
Which group are you?
He's group 2.
No, I'm not. I'm group 8.
Group A? Okay, we don't have any more time. We got the rest of the groups to ask their questions to. Which group are you?
We're group 9.
Okay, go ahead.
Hey, I was just wondering if you guys could talk about page faults, why exactly a page fault happened and whatnot.
Well, a page fault is basically when a program goes to look for a certain page and it's not in memory, it's on the disk. And then it will need to go get it off disk, put it in memory.
Question right off the card, I didn't show him.
Does that always cause like a fault, or is that just under the operating?
It's just an error that occurs like any other error. Like, whoops, it happened. Like, oh, that page I had 5 seconds ago. Ooh, it went away. Now I can't find it.
So it doesn't split screen.
No, it shouldn't. I mean, your program will crash, but your operating system should be fine. Unless your operating system interface is still there, but that's someone else's problem. I don't know how that happened to you. Right. How many groups do you have left? You already asked a question.
Okay, can we have group 1? Anyone from group 1?
Yeah. Can you explain what happens exactly when there's a segmentation fault?
Segmentation fault.
Yeah. A seg fault.
I had notes on those. I mean, segmentation is effectively just breaking up your memory into chunks so you can actually have a fault. Never actually heard of a segmentation fault.
So like a thing, like a seg fault? You ever heard like a seg fault before?
Heard of it, but I didn't come across it in the book or anything.
Yeah.
That's segmentation.
Okay.
So.
Well, never mind then.
No, screw it. We're gonna go through that. We're gonna spend 20 minutes talking about that. What context did you hear about segmentation fault?
Just like program tries to access like memory outside of its address space. That's a segmentation fault.
Okay. Is that what behind is actually?
Here's the question.
How does paging and segmentation relate to the security and like user separation of a multi-system?
Which group are you?
Paging is more of like an implicit thing that the system will do, whereas segmentation is something that you do logically that the programmer is aware of to do things. So like you could separate users into segments.
You just protect those, I guess.
Okay.
What do you mean by protection?
Protection is like read, write, or execute for that segment. Yes. Your question?
Yes. Oh, so I'm starting to get this. The point of segmentation is to put related pages into individual segments to speed up memory processes. Does it speed up the memory process?
It can, but it's mostly made to make it easier.
So it's mainly to make it easier for the programmer to understand?
You see how easier.
So that's the only purpose of segmentation. It doesn't really speed anything up, it just makes it easier to look at.
Yeah, I mean, it's a logical abstraction.
Okay,
Oh,
that makes more
that's
sense.
what
I didn't even know the purpose of it until now.
Not just for look at, but then you can also, like they said, protection. You can add a specific.
Okay,
So
so
the users in this section.
separating things by the user or by the program that has all these pages.
I don't want the program in this segment. to
Whatever
affect
logical
things.
thing. Okay, that makes sense. Segmentation is just for us.
Sounds good.
Alright. Did we have group 4 ask a question?
These are pages.
Now,
How much memory you're taking up. And when you don't even know this, you wouldn't get it.
Is there anyone here from group 4?
Oh, back in.
In the textbook, it says that after the system's been running for a while, the memory is divided up into a number of chunks, some containing segments, some containing holes, and that's the process of checkerboarding you showed. I'm just not really clear yet on how exactly it goes about doing that, like how checkerboarding forms. I've been looking at the diagram, and I can't really visualize that easily. Could you just maybe run through it one more time?
Oh, you talking about this?
Yeah.
Alright, sorry, it went a little bit fast. So here we have segment 0 is 1, 2, 3, 4. So segment number 1 got thrown out. That process ended. So now we start with segment 7, takes its place. However, segment 7 only takes up 5K worth of memory, while segment 1 took up 8, which means now we have 3 unallocated space. It's just blank and empty now. And it continues going through this. The next one to go is segment 4, which is then replaced by process, or segment 5. Each of the segments represent processes, programs that are being run and then either end their process or are terminated. Well, their chunk of memory is still a chunk of memory. It doesn't change at all, and new processes take their place, typically either at or smaller the memory space they were taking up before. At the end, where we get to part E, at the end of where we get to part D, we have something similar to this, where we have just a bunch of Swiss cheese of empty memory that's not being used. And like I said before, now you have 3K, 4K, and 3K again. Most processes for this example wouldn't be able to fit inside those. So this is where we would perform an action to basically move the segments down to free up some of that empty space to make it a larger empty space. It's similar to defragging your hard drive, and that's basically the same process of what we're doing. And it's not easy for your system to do either, so you don't run it constantly while you're taxing your memory system. But that's really just what this chart's meant to represent, is just a quick, simple form of here's what segmentation is, and
So wait, that final conglomerate of it becoming a big piece of a bigger piece of memory, right? You know what I'm saying?
like this is a
That's called
process
compaction, right?
compaction.
Compaction, is that correct?
Yes.
That's the word right there. I don't know.
Of checkerboarding by compaction.
That's just part of segmentation. That's not.
I believe compaction is something you have to actually trigger.
Okay.
So in
I
terms
didn't know
of
if that was.
has to be part of segmentation, not really.
I'm just curious.
You
So-
are curious.
Yeah, whatever. So the segments that you can compact them easier if they're part of large segments as opposed to smaller random programs. Because you can just move the segments around.
That's kind of the thing with the candy bars, right? Because now they're smaller to use because they're pages.
Does it actually move them?
Not really. It's like there's a page table or a segment table that will manage this, and it pretty much just assigns
So it's
logical addresses to the compact.
So it's less of moving the programs that are actually running, and more of moving the programs that are the empty space.
Empty space.
Right?
Just
Yeah,
reallocating
okay.
empty space.
That's what I was curious about. I wasn't quite sure.
Because actually moving the memory process will interrupt the.
Yeah, that's what it sounded kind of weird at first. So
Sorry.
that works. Thanks.
Okay, and the last question from group 6.
Anybody? Group 6?
Is there anyone here from group 6?
Just push a random person under the bus and they might get points. Come on. Oh, you're from group 6? Thank you. You want some candy? Wait, think about it.
Let's see. Why is memory allocation important?
Wait, I already answered that. But let's go back to my notes. Alright, so as Eric pointed before, almost very clearly by the way, sorry, I'm just congratulating him. Memory allocation is important because memory is what basically runs the processes and programs on your computer. So having better memory allocation allows you to run multiple or more programs simultaneously or higher end programs that take up more processing power. So memory allocation is super important for that. It effectively allows your computer to be a computer. Yay.
Okay, very good. Let's applaud the presenters.